contact done today. Okay, so do you remember what is an arithmetic sequence? That's not hand up, I guess.
I just had to move this.
What's an arithmetic sequence? What makes something an arithmetic sequence? Wow. Hannah?
Would it be something that goes up in the same increment?
Absolutely. It goes up in the same increment each time. Do you remember what we call that increment? A special name? And to sign a special letter? No. N is determined as UN would be the general name instead of N. What did you say? D, yeah. So it's the D, it's the common difference. Okay? So the difference, it can be plus, it can be a positive value if it's going up, or it can be a negative value if it's going down. Okay? There was a formula that we were told, remember you're not given this formula, for the general term. So the UN, okay, so that's the general term for any term in an arithmetic sequence, was U1, oh no, it was A. We'll call it A. Oh, shush now. We started already. Deep breath, Miss Harrison. A plus, do you remember what it was?
2.
No. N minus 1 D. Okay? Which makes sense because A1 is, remember, the first term. We did say A was the first term, was it? Or was it U1? I forget.
We use A.
We use A, I think.
There you go.
Yep. So A is the first term, and then N represents whichever term number it is, and then D is the common difference. Okay? So you don't get given that. That's one you do have to learn, but hopefully you kind of think that would make sense, especially if you look back at how we actually got it. So we want to find the 50th term for these sequences. Well, we need to know a little bit more information. Can we establish the value of A for this sequence? Please tell me yes.
Yes.
What is it?
4.
Okay, good. Can we establish D? How do you do that? Subtract one term from another. Yes, it doesn't matter which one you subtract as long as you're subtracting a prior one from the one after it. So second term, take away first, third, take away second, etc. So D in this case would be 3. So if I want to find the 50th term, we're going to find U50. Okay, because that means the N is 50, it's the 50th term. And now we're going to say that would be 4 plus, should we do this bit in our head? What's 50 take away 1? 49 lots of 3. Are you with me? Sometimes doing the, as I say, the subtract one bit in your head is better because sometimes then people make mistakes with their maths and it all goes horribly wrong. So we've got 4 plus 3 lots of 49. What's 3 lots of 49? Well, what's 3 lots of 50?
1.
And then take away 3. Okay, that was a good way of doing it, wasn't it? Yes, that was wonderful. You should be a math teacher. Okay, so what's 4 plus 147? Trust me, Anne, or you could have just chucked that in your cup.
Could you just tell them all like 3n plus 1 and then put in 15?
You totally could, yes. That's your other option. Yep. The reason I'm pushing this is because we've got to look at some of the arithmetic sequences where you need to be familiar with what the A and the D are. That's the main reason. This one, A is what? D is -7, good. Okay, stick it into that formula. So we want U50 equals 100. Oh, that looks like 6. Plus, again, it's 49 because we did that in our head. Now this is multiplied by -7. Be careful again, sometimes people write it down correctly and then they start doing 49 take away 7 and adding it to 100. It all goes horribly wrong. Okay? So this is 100, and what's 49 times -7? Don't rush. Not that. We could do the 50 times 7 again. Okay, and I notice I've gone from being plus to now being take away because it was a negative value. So we're now doing 100 subtract 343, which gives us -243. What I would like you to make sure that you're doing when we're doing these kinds of questions, or if you've got them in a test, is please double check that your answer looks like it could be right. Okay, you don't necessarily know it's going to be for sure. But if you had done something silly here and done 49 take away 7 and added it to 100, you'd have 142. Now, is the 50th term in this sequence going to be 142? I would hope you'd all go, no, that's ridiculous. Okay, so if you're thinking, no, that's ridiculous, then it's not going to be right. So double check what you've written down. Okay, I can't stress enough when it comes to the real exam, and now I'm going to, hopefully when I'm saying these tips to you now, in the past you may have gone, oh yeah, what else? But it's close enough that I'm hoping you're going to remember them. So always look, does your answer make sense? Is it look like it could be right? You can often catch the mistakes you've made. Alright, for the following sequence, calculate the number of terms. Okay? So this here is showing we're going up in a number of things here, but there's a gap, and then this is the final term. So that's indicating it's the final term. Okay? We need to know how many terms that is. So in other words, we're finding n for this particular term. Okay? A good way of doing this is to write down an expression for un. Now you can do it in the way that you suggested, Emma. Okay, so you can find that rule if you wish. Or you can say, right, un is going to be 5 plus n minus 1 lots of them. What's my common difference here? 4. Yeah? So we've got un is 5 plus 4n minus 4. So that's 4n plus 1. You all happy with that?
What is it for?
Yeah, expanding my brackets, yes. You could have equally got that by finding the difference and the term. So we've got our expression for that. If we know that our term number is 805, we need to find the value of n. So what are we going to do? So we would say 805 equals 4n plus 1. Yes, you're happy with that? And we're trying to find the value of n. So what would we do? We solve it by doing what? Subtract 1 from both sides, so we get 804. And divide both sides by 4. Okay, so there are 201 terms in that sequence. Now, is that making sense to see what we would actually have to do? Yes? So we've been given the last term, and we've been asked to find how many terms there are. I'll give you a little bit of time. You have a go at those ones, okay? Hopefully you won't. All right, did we get those values? So we had our rule as 5n for the first one, so n was 40. The second one, 3n minus 1, so it was 150. 10n minus 1, so it was 200. 5n plus 6, which is 29. And 4n plus 1, which is 102. Yeah, we're all good with that? Yeah? I'm going to push on. If you haven't done all of those examples, just maybe come back to those afterwards and just double check that you're good with them. But the method for them all was the same, so you should, I'm hoping, all good. Right, here this one's a little bit different. So here we're told the third term of an arithmetic sequence is 20, and the seventh term is 12. We need to work out the first term, okay? So we do, there are different ways of doing this. I would suggest this is potentially the easiest way. So, I think we did one of these the other day, but I don't remember. Right, so we know that the third term, so we know that U3, so the third term is 20, okay? Can we write a formula or a rule using that un equals a plus n minus 1 d? Do we know a and d? No. But we do know n, yes? So we know that that is equal to a plus 2d. Are you happy with that statement? is the third term. Okay, so n is 3. That's the only thing we know. Okay, so if n is 3, then this portion here would represent it by 2. So we could say that 20 is equal to a plus 2d.
Because n is 3.
Because n is 3 for the third term. Yes? You with me? Similarly, u7 is 12. Okay, so if u7 is 12, that would be equal to a plus what? 60. Nice. Now this is where I'm hoping you're going, oh, because how many equations do we have?
Oh, it's a
no.
We have 2 equations, and we have how many unknowns? 2. So what do we do when we have 2 equations with 2 unknowns, both the same letters? Simultaneous equations. Okay, so we've got equation 1, we've got equation 2. Obviously, we're now ignoring this part of the statement. So we've got 20 is equal to a plus 2d, and 12 is equal to a plus 6d. If you recall, then we're going to change, we need to have them the same value but opposite signs. So here I can see I've got both of them are positive a's, so I need to change one of them all to be negative. I'm going to change the top one to be negative 20 is equal to negative a minus 2d.
You could do the other one.
You could do the other one if you wish, yeah. I have now got a positive and a negative a, so I know that when I add those 2 equations, that's going to disappear. So I've got 12 plus negative 20, which gives me negative 8.
You have to add, right?
Yep. Well, you don't, yes. I'm going to say yes. And we've got positive 6d plus negative 2d, so that gives me positive 4d. And so d is going to be negative 8 over 4, so d is negative 2. Okay, so I found my value of d. But that wasn't what they asked for. They asked for the value of the first term, which is represented by the a. So what are we going to do? Substitute into one of those original 2. Actually, you can do it into any of them. The red one and mine as well. And it doesn't matter which one we pick. Let's substitute. So we're going to substitute d is equal to negative 2 into equation 1. So we've got 20 is equal to a plus 2 lots of negative 2. So 20 is equal to a minus 4. Oops. Add 4 to both sides, so a is 24. So the first term they are quite common questions, and it could definitely be a situation where they're going to stick that in because it's getting you to solve simultaneous equations, especially if they haven't asked you one of those in the earlier part of the paper. Yeah. So I did say there are other options. So you could say, you can see how many differences there are between the numbers. So there are alternatives, but this is going to work no matter which term it is, because if they've told you what third term and the 27th term is, that's going to be harder to work out. Yeah? Okay? We agree with that? Yes. Oh, I'm so sorry. When you pause it, are you close to it? Okay, good. Alright, so that's about arithmetic sequences just as a sequence, okay? In some cases, what they're going to do is ask you about the sum of terms. Now, they do give you this formula. Okay, so you don't need to learn this. They do give it to you. The A's and the N's are represented by exactly the same things as they were before. So A is the first term, D is the common difference, and N represents the number of terms that you're looking at. Okay? The S gives it away in that they're looking at the sum of the terms. So literally, what they're looking at are situations where they would say, right, I've got 8 terms. If I added those all up together, what value will I have? Now, there's a fancy pants way of showing you how this is derived. I'm not showing you that because I don't think it's that important, and because you get given the formula as well. But basically, you can see that the number of terms is divided by 2. You've got 2 lots of the first number plus n minus 1 lots of d, and you're multiplying that by that number of terms divided by 2. So we need to establish the value of n, a, and d if we're going to do this. So for this question here, what's a? What's d? And what's n in our case? It's not a trick question. 8, yes? Because they want 8 terms, yes? You're just going to stick those numbers in. So the sum of 8 terms is 8 over 2, brackets, 2 lots of 3, plus, let's do this bit in our head, I keep saying, so 8 minus 1 is 7 lots of 4. Please be careful if you're using your calculator for this, or if you're doing it in your head. Actually, the calculator is better because you can just stick it in as you see it, using brackets, using everything that you see there. And if you do it by hand or in your head, sometimes that's where mistakes are made. So we've got 4 lots of 6 plus 28. So 4 lots of 34, which is 136. Okay, so the sum of the first 8 terms of that sequence would be 136. Again, double check, does your answer make sense? If you're adding up numbers, you can see they're getting bigger each time. It's not going to be a small number, okay? Now this one here is a little bit different because they haven't told us what the end point is. Well, they haven't told us how many terms they want us to add up, okay? But they did tell us what the end point was, yes? So what do you think we might do? Solve for that. So we're finding the value of n, yes? So we're going to find n using that 41. So we're going to say 41 is equal to, should we do the easier version? Yes. Okay, so what's our rule for this bad boy? Okay, good. So we're taking away 5 from both sides, so we've got 36 equals 4n, so n is 9. So we know that there are 9 terms that we're finding the sum of, so it's S9, so that's 9 over 2, brackets, 2 lots of 9, plus 8 lots of 4. So hopefully you're thinking, well, this is all right, it's not too bad. And away we go. So 4.5, lots of 18 plus 32. So 4.5 times 50. Oh, I don't know what that is. What do I want? 225 next.